Okay, so we're solving LeetCode 242, which is to check if some simple lowercase English words are anagrams. And that's very simple. We just need to compare the sorted words. And since strings in APL are actually just character vectors, character lists, then we can sort them directly. There's no need to uh, break the list, the string into a list of characters or anything like that. One slight snag is that APL doesn't have a sorting function. Instead, it has a grading function. So I'll just show how that works. So the grade function looks like this. It kind of points up because we're grading now ascending, which there's also descending grade. And what this gives us is the indices that we need in order to put the given array in the sorted order, ascending. So we need first element number 1, then element number 3, those are the two A's here in the beginning, then element number 6, that's the A at the end, then number 4, that's the G, and so on. So if we take these indices and use them to index, and APL supports multi-indexing, so you can have many indices inside the indexing brackets, and that will just select those elements in that order, then we get it sorted. Okay, so if we take this sorting algorithm, if you want, and put it into a little anonymous function, a lambda, we call them defins, where the argument is represented by the Greek letter omega, then we can write it like this. And the underscore you see here, that is actually APL indicating to us that it understands what we meant as sorting. It's not actually going to go through the motions of grading first and then sorting, because it's faster to sort directly than computing the grade. So there's an optimization there. Of course, it gives the same result. And now we need to sort two arguments and then compare them. So the comparison function is the match function we're going to use. And then we have a combinator which pre-processes both arguments to a main function. So the main function here is the comparison function, and the pre-processing function is the sorting function. So this pre-processes both arguments with sorting and then throws the results to the matching function. And this whole thing, this combinator, it combines this whole thing into a single function. So we can see that's true. APL uses 1 and 0 for true and false. So now we can give it a name. And then we can use it like this. So we substitute that with, so it's an infix function, a dyadic function, takes two arguments. Some people like to call this a binary function. It's a bit ambiguous because maybe it was using binary bits. That's not what's going on. And then the problem statement actually goes on to ask, what if you were supposed to take Unicode arguments? How would you modify your code? Answer is, I wouldn't, because APL handles Unicode just fine. And that's it.